Hello, everyone. Welcome to this evening's webinar, Math Resource Fixer-Uppers. We are going to get started in a few minutes. We just want to give everyone a chance to join. But in the meantime, I want to draw your attention to some of our engagement resources. At the bottom of your screen, you'll see a blue icon. That's your group chat icon. Feel free to introduce yourself to all of the other attendees. Maybe there's someone who's currently present who's in your network as well. You never know. The green button is for resources that are being discussed this evening. They are able to be downloaded or accessible through the internet. So we'll be right with you in a couple minutes. Okay, welcome everyone to this evening's Core Advocates webinar, Math Resource Fixer-Uppers. My name is Pascal Joseph. I am a project coordinator with the Tools and Classroom Resources team at the Student Achievement Partners. I want to introduce this month's presenters. We have Jason Zimba, a founding partner for Student Achievement Partners, and Elizabeth Meyer, the Innovation Development Manager for Student Achievement Partners. Before we get started, we just want to know how many Core Advocate webinars have you attended? This could be your first one, or this could be your 20th one. Let us know right on the poll that's on your screen. Wow, we have a lot of first-timers. Welcome. Thank you for joining us this evening. I'd like to introduce you to joining our network, especially for the first-timers. Our Core Advocate Network is a means for you to get access to free resources or even training opportunities provided by Student Achievement Partners. If you have any questions or want to learn more about us, contact Jenny Beltramini or Joy DeLizo Osborne. You can also take this survey. The link is right here to access our mailing list. Also, feel free to reach out to us on Twitter using hashtag #CoreAdvocates. Again, there are several ways for you to engage with us this evening during the webinar. There is a purple button, that's a Q&A button that is for asking any tech help or if you have questions just for the presenters. The green button is for resources. That is all the resources that are going to be discussed this evening that can be downloaded. It also includes this evening's presentation. The blue button is group chat, where you can all chat amongst each other and connect with each other about all the discussions. So without further ado, I'm going to pass it on to Jason, Zimba, and Elizabeth. Thank you again for joining us. Go ahead, Jason.
Thank you, Pascal. And welcome, everyone. And I would say good evening, but we have participants from really across the globe here today. So for some of you, it's good morning. For some of you, it's good late evening, and thank you for being here. Let me catch up on the slides. Excuse me. And we can move to the agenda for today, slide 8. And the first element of the agenda is an introduction. We're in the introduction, and we only have a couple more points to make on the introduction. One of the first and most important being some of our norms for today. and my audio went out. My audio is back. I'm sorry for the glitches here in the beginning.
Liz, are you there? Can you? Here we go. I think why don't you let me
device just refreshed.
Great.
So why don't you put us on a number? Let me know the slide that we're on.
Great. So we're going to get started with a poll question to learn a little bit more about who you are out in the audience. I see folks have been introducing each other via the chat, which is great. But we also just wanted to get a sense of the breakdown of grade bands with which folks are working with on a day-to-day basis. So you have three options here. If you're working primarily with either K-5, 6, 8, or high school students, you can just make a selection. And then we'll take a look. So it seems like we have about 73% of folks working with K-5, 37% with 6, 8, and 20% with high school. So a great range here. And we'll be touching on content from all of these grade bands tonight. Okay, so Jason, do you want to go through some of the norms here together for the next hour?
Yes, and the first thing is easy, and a lot of people have been doing it, and you'll see this icon a couple times throughout our time together tonight, which is the group chat icon, and we'd love to see you thinking out loud, commenting on each other's thinking, follow-up questions for Liz and myself to elevate, and the way I like to think about this is by the end, the list of comments looks like a transcript of a productively noisy classroom, and I see that we have a lot of activity going on there. More generally, your questions and voices are welcome. We're here for you and your curiosity and learning are what we value. You can take risks. You can ask a question, whatever's in your mind. Feel safe taking a risk asking it. And all of us here today want to ensure that we promote each other's positive views of students, our high expectations for students. We will respect the value of students' backgrounds, languages, cultures, points of view, knowledge, and skills in the curriculum and instruction mathematics that we discussed. Be critical thinkers about representation of multiple perspectives and identities. And if you could, use the group chat with a thumbs up or something like that to let us know that you can embrace our norms for today. Do that, that's great.
Great, thank you all so much.
Good, keeping our eye on that, maybe we can move to the next item on the agenda.
Sounds great. So to start off our time together tonight, we thought we'd do a bit of an activity together. And Jason came up with the title for this. It's called Good Thing, Bad Thing, Change One Thing. And actually, before we jump in, Jason, I wanted to know if you could sort of tell us, where did you come up with this idea?
Yeah, so one of the ideas behind Good Thing, Bad Thing, Change One Thing is that anytime you look at a resource, maybe you download a worksheet from the web, or maybe you open up a textbook, or someone has asked me to look at something, it's easy to be critical right off the bat, and it's good to remember that someone made this, and they had an idea of what they wanted to accomplish. So we honor that by, at first, saying something good about what we're seeing. And then we're allowed to, let out a breath and say a bad thing, and then it's on us to think about, well, what one thing might we change?
Great. So let's go through one together. We'll look at slide 13 here, Jason. So the problem reads here, if the two lines in the graph below continue increasing at a constant rate, at what x value will they intersect? So what about this one, Jason? What's one good thing you see?
Well, before we play the game, I just want to point out something that may be obvious here, which is, there's no brand name on this problem. You may have seen it before. You may recognize it. That's not the point. It's not to be printed out and used. It's not. It's here for purposes, as it were, of scholarly discussion. And the game of good thing, bad thing, change one thing is not a classification exercise where we say, we put a good thing here, we put a bad thing here. We're looking at what we're looking at, not classifying it. And so it's a little more like notice and wonder than it is an evaluation exercise. So I just wanted to point that out. There will be problems, tasks, other things, artifacts that we look at that I have written, and you should feel free to print those out. And there'll be a little JZ on those. But I just wanted to get that out of the way, that we're not interested here in classifying things or where they came from and so on. So with that preface, I would say there are a number of good things, in my opinion, about this task. One of them is that there are ways of solving it, and I'm sorry we don't have time to pause and let everyone work on it, but there are ways of solving it, as you can imagine if you think about it. There are a spectrum of algebraic or symbolic intensity. There are some very concrete numerical approaches to this. There are some fairly sophisticated symbolic analyses of these lines in the plane. And one thing that's nice about that is you could imagine students falling along that spectrum in different places, and then you can leverage those differences to move students and have them better understand the mathematics of the problem. That's a good thing.
Great. So on to the next part. What's one bad thing?
Bad thing, this is just small observation. It's very hard, I think, on your screen. I tried to make them as big as possible to read the numbers on the axes. But the note says that X and Y axes are not included in the graph. That just confuses me because all the points along the bottom have a Y coordinate 0. So I'm wondering why that's not the x-axis. So I'm a little confused by the parenthetical of that.
Yeah, that makes sense. And what about the last thing? What's one thing you might change in this problem?
Yeah, so and this there's a blurring here of ideas about functions and of one variable and ideas of two variable equations whose solutions graph as lines in the coordinate plane, lines being geometric objects too. And so I might, in the first sentence, it mixes some function thinking with some line in the plane thinking. I might try a variant of this, which would say something like, what are the red line and the blue line are straight. What are the coordinates of the point where they intersect?
Great. And do you want to say just sort of one sentence about why that change improves the problem, Jason?
Well, one might say it's a different version, but it was flagged for me by this kind of odd blending in the first sentence where it talks about lines increasing. And, lines are geometric objects, functions are things that increase. And I feel like sometimes when there's a blurriness about that, whether we insist on this distinction explicitly with students or not, but when there's a blurriness in the way we talk or frame things, that it's hard for sharpness to emerge.
Great. Well, that helps. I see you guys in the chat are already ahead of us. You've been chatting in some of your good things, bad things, and change one thing for this assignment. So that's great. So speaking of that, we're going to turn this to the audience a bit and let you guys take a turn on a different assignment. So we're going to show an image of a new problem, and we'd love for you to take a few minutes to read the assignment, do a problem or two, and then use the group chat to chat out your good thing, bad thing, or change one thing for the assignment as a whole, and then we'll pull out some items from the chat to talk about together. So here's your assignment. Great. I see lots of good, lots of bad. Maybe folks can give us a couple changes. Great. So I see lots of great answers coming in. Jason, do you want to comment on any you've seen?
Yeah, so I'm noticing a number of things, but I'll just pick one out without promising to be representative. Someone pointed out that it's a lot of problems, and it's not on its face exciting. It doesn't jump out at you as a thing you might walk across the room to pick up and do. And both of those things together, I think they raise, they make us wonder, well, what is the setting for this assignment? Is this a worksheet that goes home? Is this scaffold for a classroom discussion? And all those things I think would matter. Some other very concrete observations I like about space and the format of it. Some of the good, bad, and change are along the lines of things that I thought myself or would have thought about it. So want to practice the discipline, the good thing. A general good thing about this, I think, is that when people say mathematics is the study of patterns, this is more what they mean than the kinds of exercises I often see, like circle, triangle, square, what's next? That kind of patternology somehow elbowed out the mathematics that gets done when we look for patterns, which I think is pretty sad. But in this case, we're looking for patterns and being mathematical as we do it. And more concretely, something that grabbed me about this was this phrase, complete the table to explore. Just think about that phrase by itself for a moment, the beautiful economy of it, completing a table to explore, the beautiful efficiency of it. When we take the constraints of these table cells and marry it to a kind of a really legitimate mathematical exploration. Time's limited. You have to be efficient. A bad thing, I think, is there's not space. So in working through these patterns, we gain some insights, or anyway, that's the intention, I think. there's not a space to record that insight or to commemorate your aha here. In terms of change one thing, I think, just trying to be very, very small refinement, I think it might have been interesting to put, a fraction case in here instead of so many of the rows here, like something like a third raised to the third power times a half raised to the third power, stressing that, these properties are general to the rationals. I take it that the 6 here refers to 6th grade. So we're getting on to that area. Notice and wonder explicitly from Sarah Al here, letting the kids do a bit more. These are all great.
Great. Well, thank you guys so much for that. So now we're going to keep us moving to the next part of our agenda here tonight, which is taking a look at improvements overall to assignments. So Jason, you and I see many assignments over the course of our work together, and we'll take the next chunk of our time tonight to look at some of the themes of improvements that we might come across in some of our work. On the left here on your screen, on the slide, you can see a typical worksheet on place value that you can get from the web by Googling. And on the right is an assignment that you made, Jason, actually, and it eventually was the first mini assessment we ever posted on Achieve the Core. I don't know if some of you in the audience tonight maybe have used it. So I'd love for you to walk us through, Jason, what do you see as some of the important differences between these two place value worksheets that are trying to get at the same content here?
Yes. Well, I'm going to keep to the discipline of good thing, bad thing, change one thing. And before I kind of get into what problem that I wanted to solve here, let's honor the good in this. There are a couple good things that I found interesting here. One being that they mix some 2-digit examples in, and in other ways move the zero quantity around for some of the units. Bad about this is, well, for one thing, I think kids are really sharp and they will learn the game you want them to play. And I think one quickly learns in this case that the game that you want people to play is to put the first number in the first space, the second number in the second space, and the third number in the third space. And that doesn't help learn or assess or build some of the subtle understandings of place value that have to happen. So in this case, rather than change one thing, I kind of went back to the drawing board and wrote problems like those that you see on the right, in which the concern is much more about the size of the units, the way they recursively bundle and unbundle, the way comparisons follow from that, and all the components of place value. Again, trying for something similarly economical and efficient, but that is much more directly tied into the mathematics. Other differences, I suppose I could mention another difference is draw a picture if it helps. So they're going to use the tools that they have to the extent that they want to rely on them. And there's also just a kind of a general concern here with truth. And whereas on the left, there is a sort of, are you doing what I told you to do? Big difference.
Yeah, I can see that now that you point that out. Great. Well, thank you for that introduction. So now I'm going to move us on to slide 20, Jason. And here you have a list of some of the small and gradual improvements that someone might make with an assignment. Do you want to walk us through some of these?
Yeah, and I won't read them all. We'll take them more or less in order. And it starts roughly with the most important or overarching one or a theme of what we're going to talk about today, which is to challenge your students. So let's get into that one. let you
Great.
read this.
We're looking at slide 21.
Quote from I'll let you read this quote from the very recent third Catalyzing Change book from NCTM. It was a great read, and this is a good reminder that students want to be challenged in these ways. So let's get into some cases. These first two problems caught my eye. They're from a mathematical Olympiad for elementary students. And so one way to think about challenging your students is to take things that were formerly thought to be only for some kids and give all kids a chance to think about them. Those are division signs in the second one. They look a little like plus signs. These are not necessarily problems that we teach kids routines for. Well, the first one is a word problem of a familiar kind. The second one, that's not a routine problem. It's not something we teach an algorithm for. But there's some important and interesting mathematics going on there. I like Heidi's comment, children require it. Great. Let's look at another example. This is the problem I made, so I explained this little JZ at the bottom. It's not because I want credit for writing a problem. It's to let you know that this came from a choose the core type situation where everything is for open use and so on. So this was a problem I wrote. It's primary grades, which is greater, and the zeros here. It's almost silly. All these zeros leading up to the 50. This is not a routine problem, but it's silly, but I call it seriously silly. The piling up of zeros here is obviously about some important mathematics, about the identity property of zero, and it's kind of funny, and it can kind of wake you up because it looks different. Also, another thing we're looking at here is we're looking at expressions as objects, things that can be studied. Think about mathematical practice standard number 7, about looking for and making use of structure. I think probably the key version of that in the elementary grades is to look at an expression, hold off for a minute on evaluating it, seeing it as more than instructions to calculate, but as an object with structure and meaning. Here are actually four different worksheets along the lines of developing the theme of which is greater, and some of the analyzing expressions and operations and the way they work. These, for example, the problem 637 times 322 that you see in the upper right, compared with 322 times 637. These products were well beyond the algorithmic skill of the students, and so there's, in a way, no help for it but to be algebraic thinkers and think about the properties and what it means. And in a couple of cases, they turned out to be too hard to think about, and so we got into drawing some models and thinking about it. And again, some of these look a little silly, like the lower right is 3/3 times 8/8 compared with 9/9. It's almost silly, except that there's some important properties going on there. And this, I think, is one version of thinking of arithmetic as not just a literacy that's essential, but also as a rehearsal for algebra. I mentioned earlier patterns and this bugbear of sequence problems where they show you a sequence and they ask you for the next term. I think we can often make those problems more interesting if we give the rule for the sequence as it is here. This is my handwriting. Start with 256 at each step, divide by 2, repeat forever. Forever is another challenging or exciting idea in math, that something can go on forever. And in part A, it says show 4 steps of this sequence. And it says that to try to fool the student into thinking that they'll all be whole numbers, but then in part B, we prove or disprove whether every number is going to be a whole number. And we get some practice writing mathematical argumentation. But the tweak here was tell the rule for the sequence. Guessing rules for sequences is not nearly as exciting as doing mathematics with them. Also, this student needed some practice with multi-digit division, so that was a sneaking in. Here's a case, and I want to do good thing, bad thing, change one thing with it. This is finding the good thing here is a little harder. The vocabulary sheet about polygons, it's at totally the wrong grade level. There's a lot of things I can talk about. I'm supposed to start with one good thing. I'm gonna do that. A good thing here to me is that there's a structure where asking about sides and angles is building up, or supposed to build up in problem 11 to a pretty significant mathematical question of does a polygon usually have more sides and more angles is the way it's expressed. So that's a good thing. The bad thing, let's not dwell on it. But the change one thing, looking at problem 10, name 4 types of quadrilaterals. I think a change one thing, and you change one thing, if possible, draw a quadrilateral that isn't one of the 4 types you named. It could be easy to get the impression, reading the standard U.S. curriculum, that these are the only kind of quadrilaterals there are, but they're pretty special. In fact, this exercise of exploring the space of quadrilaterals is much more explicit in the standards. But adding it in is also a move toward alignment. There's this thing I wanted to show. I'm seeing in the chat talking about no visuals, and there's a visual coming that I think it's the next slide, is that right? In relation to that. This is the output of a computer program that I wrote to generate quadrilaterals randomly. There's 100 of them here, and you won't find a square in the bunch or a trapezoid. Random quadrilaterals are pretty exotic, and it might be nice for someone learning mathematics in school to have a sense of this space and to have a sense of why it might be useful to key on these special quadrilaterals. It's a little like, a good way to understand what a mammal is to wrestle with the platypus idea. The first time you see a platypus, it challenges your notion of what a mammal is. It makes you be explicit about the properties that define it, about what's essential about it, and what the corners of the idea are.
So Jason, we're looking at slide 29 here. So I think we'll have Jason call back in a second here. Here we have a poster that Jason actually took a picture of in one of our classroom visits. And you can see here that let me go back one, excuse me. That there are a few formulas here that we might hope students don't need explicitly laid out for them, but instead could derive themselves. So we have the area of a circle and the area of a semicircle. And in this work, we might hope that students would be able to apply 1/2 times pi r squared without needing that on the poster themselves. So another example of how we choose our supports carefully to ensure that they're grade level appropriate and keep challenges within our classroom and with our students. We're going to give Jason just a second here. He's calling back in. I see some great suggestions in the chat here about adding visuals. Hi, Jason.
And we're back.
And we're back. So I just went through slide 30. We're looking at slide 31, that poster that we saw in a classroom together.
Yeah. And that's good. I'm sorry we missed a few minutes there. I think maybe we're going to have to accelerate. Have you described what the yellow circles refer to?
No, not quite yet. We got to sort of the challenging aspect of ensuring we're not including area of a circle and area of a semicircle as much as possible on a poster, and have you fill us in here with the rest.
And not to skip past the good, the one point of this is to wonder, really it's a wondering, and we didn't get to have the conversation at the time, but what are the costs and benefits and trade-offs of putting, a formula 1/2 pi r squared when there's already the formula pi r squared, and what things that enables students in the class to do, and what things that doesn't permit them to do. One thing, since we're on the theme here of challenging students, one subtopic there is what to do for enrichment, when someone's ready for additional challenge. And this is my colleague Shelby Cole, if some of you may follow her on Twitter, posted a grade 2 enrichment worksheet that just grabs material from the middle grades and puts it in. And so a way not to challenge students is to, once they're done with this year's superficial problems, to start giving them next year's superficial problems. Better to keep the mathematics that they're studying on grade level, but increase the challenge in other ways. So that rounded out the challenging students. So I also want to make the point that in terms of worksheets, assignments, there's no need to complicate what is simple. There's times when the right tool for the job looks like this. This is a practice sheet that I made for making 10 in first grade, adding single-digit numbers using making 10. It's not the first approach that is going to be most comfortable for students, and so I get practice in it. And for that matter, wanted to know where are the thorny spots? Where do we really have to concentrate our work? So it says here, if you know the sum, just write it down. That's the target here. But there's going to be ones that are not known, not remembered, and we want to practice a strategy for that that's going to help propel us into place value work, which is making 10. And these are the 36 single-digit sums for which making 10 is great. I see a chat. This is busy work. That's great. Fight with me here. Sometimes I think we need to be busy. And, yeah, interesting. Yeah, interesting. I think this is a kindness because making 10 is hard. Good, good. I like this. There's another place where I think simplicity is the order of the day. Let's start with the bottom one. It's a little easier to see. The problem is 17 plus 68. And to begin with, make a ballpark estimate, which is good. Ask for the strategy. There's a beautiful strategy annotated here. And then it's a bit overkill to explain the estimate. We've explained the strategy. We've made the estimate. I think at some point, time is of the essence and we can lay off. Likewise, this is an assessment up at the top where the student buys scissors and with 70 cents and has 40 cents left over. And we do the word problem, and then the student has to show accountability to the conventions of the curriculum and say, how would you have used the number grid to do this? So I think for those things are means, not ends, and to not assess them as ends. So this raises a host of issues about fluency and calibrating on it. And the distinctions that I want to draw here are about elementary versus middle grades. And in the elementary grades, alongside many other goals, the K-5 teaching has to endow students with these important procedural fluencies that build steadily across years of schooling, and they're familiar from the standards. And students spend a lot of time over the years learning the ins and outs and the reasons for this. And in contrast, what's going on with grades 6 through 8 is a somewhat more complicated story. And the observation I want to make is that we're using time inefficiently if every topic is construed as a procedure and every procedure is reinforced to fluency. There are pointless fluencies, unnecessary fluencies that we can spend too much time investing in repetitive problems about. Determining the median value of an artificial data set, factoring trinomials over the integer. The volume of repetitive practice I see in this is totally out of proportion to the value of the fluency. So this is a distinction from K-5 where there are literacies that are being built, almost like reading. So let's look at some examples. By which when I say construing topics as procedures, so here's a poster and there are good things about it. And to make my point, though, I want to draw attention to the mean and the median, which are, the mean says add up all the numbers and divide by the number in the set. So the only thing we are getting at here about the mean is how to do it, not what it is, what it's for, why we might want to do it. So that construes the topic of mean as a procedure. And then you have the volume of practice to build fluency with that procedure. You could advance that. Reams of exercises of fake data, finding the median by hand, builds a fluency that nobody needs. And that time could be used otherwise. Let's look next. Calculus assignment, the student's assignment, zillions of repetitive exercises about the same thing. There wasn't a single application of calculus in this unit. So we start to see some of the costs in terms of application. Construing things as methods. This is a worksheet about finding the square root, and there's a kind of a meaningless dispute here about who does it right, and the square root is presented only as a method, not as a thing, not as an idea. Not everything in math is a method. So looking down at the bottom of this slide, in cases like these, when we get reams of repetitive bite-sized problems, it consumes too much time that you could spend in other ways, fostering understanding of the topic, which is more durable than the fluency that you're building there, providing students with life-size problems, meaningful and rewarding, and investing in fluencies that do matter, the median not being one of them. Now, we've just been looking at sort of a litany of problems that can feel overwhelming, and so the advice is refine over time. Nothing gets fixed in a day, nothing gets built in a day, and make small changes over time. So instead of, the way I think about this is I'm kind of nuts about roasting chickens. I like to roast a chicken, and what I notice is everybody's always Googling for the perfect roast chicken recipe. I, about 10 years ago, just decided to pick one that seemed fine. And I've spent 10 years learning how to roast chicken according to this recipe, and it gets better and better. I could be still hunting for that perfect chicken recipe and never getting very good at ever using it. So likewise, instead of looking around for the perfect resource all the time, I kind of invest in something and try to make it better over time. And we'll just look at some simple cases where when you look at something, instead of throwing it out, think about a small change that could make. Like in this problem, 97 lunch trays were placed equally in 4 stacks. No, they were not. In fact, the problem is about how many lunch trays are going to be left over. So I want to reframe this. But in the curriculum, this is there's some good math here. The numbers are interestingly chosen for the place in the curriculum. The context is sensible for division with remainder. But it needs some refining the words, and then that next year it'll be better. This problem, Ryan transfers 15% into a savings account, but then we accidentally switch to Max, who is doing something else that's supposed to be Ryan, but it's fine. Problem, we can just change Max to Ryan. And we don't have to throw it out or find that other thing. This is a set of problems that I made. The distributive property is sometimes difficult to get to, and these problems are all designed in a certain way so that the math is easier if you use the distributive property. So it amounts to a kind of argument or persuasion that the distributive property is exciting and useful. One thing that didn't work in it was I had this problem, I think 4 1/4 times 36, and I didn't realize that 4 times 144 was going to cause so much trouble. So I would adjust that number next time. So doing it, learning, making a small change on the basis of what you get. Word problems, there are a lot of things one can do. Some common and valuable ideas are here about reordering questions. I want to keep the pace going, so I'll talk about another issue in word problems, which is where there's this lazy explain. There's the word problem, and then it just says explain, which is kind of lazy, or it says justify, which is sort of a category error because that's for mathematical arguments. And something I wanted to focus on here down the bottom that has worked for me is this prompt, which says, write a note to a classmate describing what your solution plan was. Don't write any numbers. And then give a sentence frame. First, I. This is hard to do. This takes a while to learn. But the results are like along the lines of, first, I added J's flowers and L's flowers. Then. So this is, you're talking about the quantities in the problem, not the numbers in the problem. And students will say this is hard to do, and we don't want to do it all the time. But this gets us talking about quantities instead of numbers, which is a more algebra-ready way to examine it. And the sentence frame is important. You could even, You could say first I added blank and blank and have students in the beginning fill those in until they get used to it and start to understand what you're after in the plan. It's very different from show your steps.
Steve, for the sake of time, I'm going to move us to the final topic here.
Yeah, perfect. Now, there are lots of word problems about, so-and-so has red and yellow marbles in a bag, and, they may serve a purpose, but they're not anybody's fascination. And it raises the question of, these are good problems, but what are your students interested in? It's actually a question, and I wanted to share a potential resource, and here's one about basketball players who love donuts. I'm not sure that really floats anybody's boat, but I wanted to share a set of ideas for tailoring the math that students do more to their interests and their identities. And it is by Jamal Matthews, professor of mathematics education, and it's really one of the more concrete ideas I've seen for integrating students' culture into mathematics instruction. And it's 4 H's of belonging-centered math instruction. The 4 H's are home, hobbies, hopes, and heritage. And I provide this link here so you can read about it. We're not going to go through it here, but one of our next steps at the end will be to read this. And it's actually intended to allow the mathematics that you do to match the students' interests, the real interests, not the ones you assume they have and not the ones no one has.
Great. And Jason, I might move us to, do you want to just say one slide here on the high school and middle school content?
Yeah, so another way to refine assignments is when you have problems that are about your learning goals, your curriculum goals, to think about bringing forward some of the mathematics of middle school into them. So here's a problem that is nominally about, quote unquote, the volume of a sphere, but it's asking about what percentage of that volume contains life. And if you click, we can see some highlighted words here. Some of the concerns of this problem are units and measurement quantities, miles and volume, percentages, and scale and proportionality. Another example, these in high school, bringing this mathematics forward is going to be valuable because you may be teaching sophisticated topics like polynomials and several variables and algebraic expressions, but it's still important that students build up their functional literacy and be ready to do mathematics in a wide range of courses in high school and later, to be functionally literate and to be able to use mathematics. And so if you are on Achieve the Core, you can see these lists of widely applicable prerequisites, and in the right-hand column are some characteristics of problems that can help accomplish this. And also on the coherence map now, which includes modeling, some of the Algebra 1, Math 1 tasks fit this bill of blending middle grades math applications into assignment. Not redoing middle grades math, not mediating it directly, not reteaching it, but giving students more reps with it and more context with it and more power with it by blending it into applications.
Great.
Of course,
Yeah, so we're just a few minutes away from actually the end of our hour here together, Jason, but I wanted to make sure you had a quick chance to just talk about your process of keeping a math problem and notebook and encouraging participants to do the same.
Yeah, so if you don't have one, a math problem notebook is just a way to make sure that you are, over time, again, refining and improving the math that your kids see. You can just click through as a kind of a tour here. I'll show some of the things that I put into my scrapbook. This was an interesting workbook page about two-digit subtraction, and the magnifying glass was really interesting because it directs the student's attention to where I want them to look. Another workbook page on Angle had a great density of ideas in a small acreage of paper. Other elements from that same workbook talking about division with remainder in terms of multiplication and addition, seeing a number as made up of multiples of a number with some left over. I wanted to learn that trick. Down at the bottom, kind of like when we looked at the pattern work, how there was an aha. Here, there's a space to write down your aha. Having looked at some examples, I learned a secret. I thought of a secret, and I can write it down. Great emphasis in this book on properties of operations. In curriculum that I see lots of concentration on order of operations. It would be nice to see more on properties of operations. And by the way, the notebook, I'm talking about you as a teacher keeping a notebook, not the students, although the students can. I love that idea, actually. Sometimes I'll find an old book in a store and go take an X-Acto knife and cut out some fun 19th century problems just to put in my notebook. Reading NCTM publications, there's always food for thought there on tasks, and can't help but take out a pen and begin to work with them. Other examples, but for the sake of time, we'll just keep moving. More patterns. Sometimes I'll just make fun of this. The Wall Street Journal had a fourth degree polynomial in 2 variables. That was weird, so I cut that out. Nice little problem from a magazine. This is a picture I just took walking around in the city, and I thought, I'll make a problem about that someday, and to have an artifact from the neighborhood might be a valuable thing. Other artifacts and examples. And we have had a great chat on the side. I don't know if we're going to have time for the Q&A because I want to talk about the next steps. Does that sound right to you, Elizabeth?
Claire's actually asking if we could take 1 or 2 questions here. So I think if folks don't mind, if we end up being 2 minutes over, we wanted to make sure. If
people promise to do the next steps, then we can do the questions instead.
Sounds good. So we'll cut it down to just a couple of questions here. But if anyone has any question about the topics we've been talking about today, how to take a look at your assignments with fresh eyes, we would love for you to send in a question to the chat.
My chat keeps zooming past. It's hard to focus on.
Here we go. Sorry, I think this is our first time doing this here. Okay, so I have a question here for you, Jason. We have a question here from Lori who said, sometimes I find a strategy used in elementary is something I haven't heard of as a high school teacher. How do I sort of learn about these various strategies that may have come from previous grade levels to help me understand them?
You know, there are a number of books published in math education, source books, a lot of them through NCTM that talk about them. I mean, some of them are oldies but goodies, like Adding It Up, and we can send out a link to some sources. I mean, I assume you're talking about certain things like algebra tiles or other middle grades manipulatives and so on, or and some of those practices and models are talked about in these publications. So I think, number one, it's great to be an NCTM member and have subscriptions to these things. There's always I have, unfortunately, it's a backlog, but I have a number of the publications to read. Now, if it's an arithmetic strategy, my advice might be a little bit different, which is to just grab hold of the properties of operations in it and make connections between the algebra that the kids are doing and the numbers. Polynomials are not really a topic. It's just the kind of extreme investigation of the properties of operations. So there are wormholes from arithmetic into algebra.
Great.
Like 9 of them.
I have a question here. For folks who already have a curriculum that they feel pretty good about, but they maybe have to modify it slightly according to some of what you've talked about here today, why is it important to continue to refine and modify a curriculum?
So some of the things that we've talked about are about alignment and moving into better alignment with the expectations. But I would say the main topic of our agenda has been more about grabbing hold of the children's brains and creativity and interest. And, in the past 10 years, we've had a lot of movement from publishers about what I might call high-level alignment in terms of getting the right grades into the right topics. But the quality is, still a question, and sometimes those topics are construed or misconstrued. And so we have a quality issue, which means that we're getting what we're getting as purchasers and as consumers. So we have to have an eye for quality and improvement, and do some DIY, and not just expect that we're going to unwrap the shrink wrap on something and have it work. And I know everyone understands that. The other thing is that right now, obviously with what's going on right now, there's more. I think students are doing more canned assignments, more PDFs, more printed worksheets. And so it may be really especially important to apply these lessons right now. We don't have those classroom communities of discourse functioning in the same way.
I have one last question here about vertical progressions and how to learn more about them. So this person already seems like an overachiever. They know about the coherence maps. They know about the progressions documents out of the University of Arizona. But given a lot of the modifications that folks are thinking of, particularly in this time, are there any other resources you might suggest to help some of our math educators understand vertical progressions or curricular modification?
There are a lot of resources on Achieve the Core about progression and different subtopics in progression, like the Fluency progression and so forth. So there may be more there than you know to check out. But I'll answer in different directions. One of the most fascinating sources of learning about progressions is the children you talk to. And you give them ingredients at your grade level, and then it's fascinating sometimes to see what they put together. And their brains are running along channels. And I think we all need to pay a lot of attention to how those channels run and how different they are and what the realm of possibilities are. And so one kind of sophisticated progression-oriented thing that I do as maybe you saw some indications, give problems that the students don't know yet how to solve so that they can approach them truly mathematically. So it's almost like running your fingers up and down the scales a little bit on a fretboard on a guitar or something like that to see the music happening. But I guess what I would say is progression documents, the coherence map, these things are good structure for us to do our thinking, but let's not forget that it's kids moving through the structure.
Great. Well, thank you so much. Unfortunately, we don't have time to get to all of the questions today, but appreciate all of the good conversation that this spurred. So there are a few next steps that we want to suggest for you to take this work and carry it forward in your work with kids. We have a few different suggestions here, but I'll just draw your attention in particular to the last two bullets. We would love if you would tweet or email us any before and after photos of an assignment that you fixed up along the lines of the activities we did today. So if you use the hashtag MathFixerUpper and tweet at either our Achieve the Core Twitter handle or send an email into our info inbox at achievethecore.org, If there's enough interest, we would hope to do a follow-up webinar with some of the problems and assignments you submit from your material. So we would love to hear from you, and that's Math Fixer Upper. And this last slide finally has a few resources from our time here today together. And I will let Pascal talk about some of the next steps for the webinar. Thank you all so much.
Thank you, Liz. Thank you, Jason. And thank you again, everyone, for joining us this evening. So the resources that are here on this page are also included in the green resources widget. You'll have access to all of these resources via your registration link this evening. So feel free to go back and listen to the audio and watch the slide presentation as well. And again, reach out, join our network. It's a national network of educators where you can connect across state networks as well. You can keep up to date on free resources, upcoming SAP webinars, professional learning opportunities, job postings, and so much more. And you can also potentially be part of creating new tools and resources in partnership with SAP. We are available on different social media platforms. Reach out to us on Twitter, Facebook, or even Pinterest. Next month, we have another webinar, Reading, Learning, Growing, Creative Ideas to Build Knowledge and Support Literacy Across Subjects. It'll be June 3rd at 7 p.m. Eastern Time. You can register here using this link, and it's also available on your resource widget. Thank you again, everyone, for joining us this evening, and I hope you have a great evening.